Okay, so let's try problem 1037 in your book. A ball is thrown with an initial velocity of 100 feet per second and at an angle of 40 degrees with the horizontal. Determine the minimum distance from a 50 feet high building from which the ball can be thrown and not hit the side of the building. Okay, so basically this problem is like this. A building is 50 feet tall. So okay, a building is 50 feet tall and a ball is hit, a ball is thrown such that this should barely clear this 50-foot tall building. Okay, so this is 50. And in this case the initial velocity is given. It is 100 feet per second and the angle is also given. It's 40 degrees, right? So we need to find this distance. We need to find this distance d to the building such that it will barely clear this building. Okay, so at a distance d, this trajectory needs to be such that at a distance d, the height of the ball is 50. Okay. Alright, so the way to do it is, because we're given the let's see, initial velocity is given 100 feet per second, theta is 40 degrees. So from here I'm going to say ux is 100 times cosine 40 degrees, which comes to 76.6 feet per second. Uy is 100 sine 40 degrees, which would be let's see, 100 sine 40 degrees, 64.28 feet per second. Okay. We don't know the time, of course, and the distance is, the height is 50. Okay, so it's thrown up, so the height is 50. So sy is 50 feet. Okay. So if you look at the vertical part of the journey, so with the initial velocity of here, let's highlight the things that we need. We're looking at the vertical part of the journey. Okay, so the vertical velocity is, initial vertical velocity is 64. The vertical height is sy, that's 50. We don't know the final velocity at the tip, so that's okay. And we don't know how long it takes. Okay, so let's find out how long it takes. Why do we need that? So this is how we're going to tackle this problem. We're going to find the time it takes to reach this height, right? The time it takes to go from A to B. Okay? By only looking at the vertical aspect, we know the vertical velocity and we know the height. From this we can find the time. In this much time, the ball has not just covered a vertical distance of 50 feet, it has also covered a distance of d, horizontal distance. We know the horizontal velocity, we know the time it takes, so we can find from velocity and time, we can find distance. Okay, alright, so let's apply the formula. because we need time, s equals, we'll use ut plus half at square. Okay, and because we're doing vertical, well, we'll say y. Right? So 50 equals uy is 64.28 times t minus, or let's say plus half, acceleration is negative, minus, here it is 32.2. Please pay attention, because up to now most of the problems were done or were in the metric unit, so we're used to writing 9.81. so just make sure that, you know, when it comes to the US customary, we use 32.2. so just keep that in mind. I have made that mistake myself, so it's easy to kind of get in the flow and keep writing 9.81. so just be careful about that. Okay, all right. So let's solve this. Now what do we need to do? So 50 equals 64.28 t minus 16.1. so 2, I'm going to divide it right here, t square. Okay, so if I rearrange this, I get 16.1 t square minus 64.28 t plus 50 is equal to 0, and this is a quadratic equation in t. Okay, so let's find the value of t. How? T is equal to minus b, remember minus b plus or minus b square minus 4ac over 2a. Okay, so here, I mean t in this case, but in general this is the formula, this is the quadratic formula, right? So minus b, so I get minus of minus 64.28 plus or minus b square 64.28 square minus 4 times a times c whole divided by 2a, 2 times 16.1. okay, so t is equal to, you get two values of t, one with plus, other with minus. Okay, so the two values of t are 1.058 seconds and another value of t is 64.3 seconds. Okay, all right. Now which time do we choose now, right? Which time do we choose? See, the reason we're getting 2 times using the same height is because the ball, this is a very interesting point, the ball is at each height. So remember I told you that this is symmetric about the halfway point. So at 2 times, twice in this entire journey, the ball is at the same height from the ground. So once here and then here, once during ascending, other time during descending. Any point you take, let's say this this height is say 25 feet, then here again it's going to be at that height at some point of time. Okay, that is why when you solve this quadratic equations, you get two values of t. One is at this point, right, in the first half of the journey, other is in the second half of the journey. Here obviously we're going to take the smaller value of t, because if we take 64, that means we're talking about the building that is here. Okay, but it needs to clear the first building to even go up to the second building, right? So that is why we take the smaller value of t. This is the first building it encounters. Okay, so we take the smaller value of t, and then what did I say? Once you have the time, right? Once you have the time and the horizontal velocity, you can find the horizontal distance. You have the time, you have the horizontal velocity, right? And then you'll have the horizontal distance. So d is equal to ux times, so d is equal to ux times t. Ux was 76.6, t is 1.058. So you get 81.04 feet. So this is the minimum distance. You should shoot this ball at an angle of 40 degrees with a velocity of 100 feet per second, so that it clears a building that is 50 feet tall.